Okay, so question 18. What have we got? A, B, C, D is a rhombus. And here's the rhombus. So you've got it drawn as a diagram there. The coordinates of A are 5, 11. So let me mark this on. Hold on. I can put it in 5, 11. So 11 on the Y, and then try and mark it kind of accurate. 5 on the X. The equation of the diagonal DB is Y equals a half X plus 6. I mean, you should probably know that the general straight line formula, isn't it? Y equals mx plus c. M is the gradient, and c is where it crosses the y-axis. That's what the equation of a line is telling you. So if I try and sketch it in, this diagonal cutting across this way from D to B is, that's the equation of that line. Y equals a half X plus 6, which means if I carried the line on, it would cross the y-axis here at 6, and also it's going up by like a half. Alright, the gradient. Every time you go along 1 unit in X, you go up half in Y. So that's what the half stands for, the gradient is a half. Find the equation of the diagonal AC. AC is this diagonal going the other way, and try and pop that in there. Okay, so things we need to know really. There's some angle facts about a rhombus that you should probably be aware of to help you solve this problem. And I'm quickly going to flick to a website to have a look. So this is, well, here's your rhombus, and I'll just play around with it to show you that something interesting happens with the diagonals. Doesn't matter how this is always going to be a rhombus, so however I pull it, it's still a rhombus shape. And you might start to notice that the diagonals, they cut each other in half, so they bisect each other. So that's half of that, that's perfectly cut in half. This plate is cut in half. And also, they cross each other at right angles. They're perpendicular. So the angle created in the middle is always 90. Doesn't matter how you pull it around, 90, always 90 degrees. They're cutting each other, those two diagonal lines. 90 degrees in the middle. So that can help us with our problem if we know that they cross each other at 90 degrees, these two lines. And you should know something about perpendicular lines. If they, let's keep that. If they cross each other perpendicular, it's a terrible diagram, at 90 degrees, the gradient, there's a relationship between the gradients. So the gradient is the negative reciprocal of each other. So if this red line, let's say, well, let's do R1. If our gradient, M, is a half, which it is on our diagram, that's our red line here, this one here, then the blue line will have a gradient of the reciprocal, which means turn it upside down. So a half turned upside down is 2 over 1, 2 divided by 1, which is just 2 really. And if this is positive, this one will be negative. So our gradient for this line here is minus 2. Alright, so I'll make a note of that, minus 2. And that helps us, because we've got to find the equation of this this line here. We've got the gradient, and we've got a point on the line. So we know the coordinates of A, which is on our line that we're trying to work out the equation of. So you can use this y equals mx plus c formula and just substitute in everything you know, and then we can work out the other parts. So there is another way to do this that's more A level, and we're going to show you the GCSE way. Just start with the formulas that I would expect you to know. So if you know that y equals mx plus c is the formula for a straight line, and you can see that there's an example of a straight line formula. Y equals a half x plus 6. M and c have values that we need to find, and normally we leave y and x in there if we're talking about the equation of a straight line. But for our line, what do we know? So we have got a point. We've got an x and a y value. We've got a coordinate on the line. We've also got the gradient minus 2. We just don't know what the y-intercept would be. We don't know what plus c would be for our line. Where would it cross the the y-axis that we carried on going up here. So let's fill in and work out what c is. So y is 11, because we've got a point on the line. Y is 11. The gradient is minus 2, so I'll put minus 2. Times x, well, what's our x coordinate? It's 5. And then we'd have our plus c that we don't know at the moment. So we can work this out. 11 equals, what's minus 2 times 5? That's going to be minus 10. So minus 10 plus what is going to give me 11. So you could add 10 to both sides if you want to solve it. It's going to be 21. Alright, so that's got our plus c values. 21. So the equation of the line, we know what m is. M is minus 2, and we know what plus c is, 21. So we could write our y equals mx plus c for the line that we're looking at. The equation would be y equals, m is the gradient, so it's minus 2, x plus our c value, which would be 21. So that would be the equation of the diagonal AC. Okay, I hope that's made some sense. I'll try to explain it, all the different bits that you need to know as much as I can. So if any of that is a bit unsure of what I was talking about, go and have a look at negative reciprocal and perpendicular line gradients in another YouTube clip.